We have all probably heard that the universe began with a great explosion known as the Big Bang. But what if that's only part of the story? What if the end of the universe is actually a new beginning? Let's explore this fascinating idea together and see what Roger Penrose, one of the greatest physicists of our time, has to say about it. Have you ever wondered how the universe came into existence? Many say that everything began from a very hot and dense point that suddenly exploded, becoming known as the Big Bang. However, Roger Penrose, a Nobel Prize winner in physics, offers another idea. He suggests that our Big Bang might not have been the first beginning. Perhaps before us, other universes existed that reached their end, and from the remnants of their demise, a new Big Bang emerged. This theory is called Conformal Cyclic Cosmology, CCC. Imagine the universe as a phoenix, a mythical bird that burns and is reborn from its own ashes. Now, what if the universe works the same way? That is, every time it reaches its end, it starts anew. Let's examine this idea step by step and see how Penrose reached this conclusion. What does the end of the universe look like? First, let's consider what happens if the universe reaches its end. Scientists say that our universe is currently expanding at an incredible rate. A mysterious force known as dark energy is pushing galaxies apart. Now imagine that this expansion continues unabated. After millions and billions of years, stars will gradually go out as they run out of fuel. Galaxies will drift so far apart that no light from them will ever reach us. Even black holes, which consume everything, will slowly evaporate and vanish through a process called Hawking radiation. In the end, what remains is a vast, cold, and empty expanse. It is as if nothing exists anymore. No matter, no energy, no light. A silent, endless void. Now, the question is, what comes next? Is this truly the end of everything, or perhaps the beginning of something new? Penrose's bizarre idea, the end is a new beginning. This is where Penrose enters the scene with a rather peculiar idea. He argues that when the universe reaches this final state, something interesting occurs. When everything becomes so dispersed and uniform that no structure remains, we can no longer distinguish between big and small, because no standard of measurement remains. To better understand this, let's use a simple example. Imagine inflating a balloon. The more you inflate it, the smoother and larger its surface becomes. Now, if you continue inflating it indefinitely, you can no longer say whether the balloon is big or small, because there is no reference for comparison. Penrose suggests that the universe behaves similarly. When it becomes so vast and uniform, there is no longer a difference between an enormous universe and a tiny point. Conformal geometry, the mathematical magic of Penrose. So, how is this possible? Penrose employs a mathematical tool called conformal geometry. This branch of geometry offers a different perspective on space and time. In this approach, instead of focusing on size, we consider only the overall shape and structure of space. What does that mean? It means that if we set aside scale, big versus small, a vast and empty universe can be exactly analogous to the dense and hot point from which the Big Bang originated. In simpler terms, when the universe reaches its end and everything becomes so stretched and dispersed that no differences remain between its various points. This state mirrors the conditions from which the Big Bang began. It's as if the universe grows so vast that it essentially circles back to a point of origin, and at that moment a new Big Bang occurs, giving birth to a fresh universe. An endless cycle of universes. If this theory is correct, then our universe did not come into existence only once. Instead, we are part of an endless cycle of universes. Before our Big Bang, there was another universe that reached its end, triggering a new Big Bang and giving rise to our existence. And after us, when our universe eventually comes to its end, yet another universe will begin. This cycle could continue forever. Traces of previous universes. Is there any evidence? Now, an important question arises. If indeed other universes existed before us, how can we know? Could there be any trace left behind? Penrose says yes, a trace of previous universes might still be present in our cosmos. But where is this trace? The answer lies in something called the cosmic microwave background. The cosmic microwave background is a very faint light that has remained from the early ages of the universe, approximately 380,000 years after the Big Bang. This light is like an old photograph of the universe's infancy. When the Big Bang occurred, the waves from that explosion spread throughout space, and we can still observe their effects today. Scientists have studied this radiation using specialized telescopes and have gathered a wealth of information about it. Mysterious rings. Penrose and his team examined this radiation carefully and discovered something peculiar. A series of faint, circular patterns in the CMB. Penrose claims that these rings could be traces of previous universes. How so? His idea is that in a previous universe, there existed enormous black holes. Over time, these black holes evaporated, and as they disappeared, they left an imprint on space and time. This imprint was carried over into the subsequent Big Bang, and now appears as faint rings in the cosmic microwave background. It's like dropping a stone in a lake. It's similar to throwing a stone into a lake. When the stone falls, it creates circular ripples. Now, if these ripples remain on the water for a long time, they can indicate that an event occurred previously. Penrose suggests that the rings in the CMB work just like that, a sign of events from a previous universe. Black holes and the transfer of information. Another interesting aspect of Penrose's theory involves black holes. Black holes aren't merely gravitational monsters that swallow everything. They might actually serve as guardians of information from previous universes. In physics, there is a major problem known as the black hole information paradox. According to quantum theory, information should never be destroyed. Yet when something falls into a black hole, it seems to vanish forever. Penrose asserts that when black holes evaporate through Hawking radiation, the information stored within them is, in a way, released. Then, when the universe reaches its final stage and a new Big Bang occurs, this information can be transmitted to the next universe. It is as if a diary from an old universe is passed on to a new one. Not everyone agrees. Of course, this theory remains controversial. Many scientists do not agree with Penrose, arguing that the rings in the CMB might have alternative explanations, perhaps quantum fluctuations in our own Big Bang or simple gravitational effects. The standard cosmological model, which states that the universe began with a Big Bang and continues to expand, still has more supporters. However, one cannot deny that Penrose's theory opens up a new and creative way of thinking about the cosmos. If there truly is a trace of previous universes, one day we might uncover this secret by examining the cosmic microwave background or even the characteristics of black holes. And who knows, perhaps one day we will discover that our universe is merely one link in an endless chain. Conformal geometry and the role of time. One of the fundamental pillars of Penrose's theory is his use of conformal geometry. This branch of mathematics, rather than focusing on absolute sizes like length and width, emphasizes angles and relative shapes. Penrose argues that when the universe reaches its final stage and all matter and energy are evenly spread out, the concept of scale loses its meaning. In this case, a vast and sparse universe can be mathematically equivalent to a dense and hot point, such as the moment of the Big Bang. Another interesting point is that Penrose suggests that in these cycles, the concept of time itself changes. This idea aligns with Albert Einstein's theories of special and general relativity, which state that space and time are interwoven and can behave differently depending on conditions, such as speed or gravity. In Penrose's Cyclic Universe, when everything reaches a uniform state, time is no longer linear and conventional, but can instead become cyclical. Penrose and his colleagues, while analyzing data from the Wilkinson Microwave Anisotropy Probe WMAP satellite, reported the discovery of a series of faint circular patterns in this radiation. They believed these rings could be indications of massive black hole collisions in a previous universe, whose effects were transferred to our universe through the Big Bang. Later, in 2018, using more precise data from the Planck satellite, Penrose reiterated this claim. He stated that these rings are real and are known as Hawking points, signatures of black hole evaporation in the preceding cycle. The scientific community has not reached a consensus. Many cosmologists, such as Paul Steinhardt or George Efstathiou, argue that these patterns could be due to noise in the data, gravitational lensing effects, or random fluctuations in our own Big Bang. For example, in an article in the monthly notices of the Royal Astronomical Society, 2011, a group of scientists examined these rings and stated that there is probably insufficient evidence to confirm the CCC theory. With that said, Penrose continues his work, claiming that with more advanced instruments, like future telescopes, we may eventually unravel this mystery. More detailed information on this subject can be found on NASA's website, nasa.gov, or in reputable scientific journals such as Nature. Roger Penrose's Cyclic Universe theory is an extraordinary idea that challenges us to view the cosmos with a fresh perspective and to appreciate the grandeur of an infinite universe. This theory suggests that our universe might be just one link in an endless chain, a chain that begins with a Big Bang and, after a cold and empty end, transitions into a new Big Bang. Using conformal geometry and an analysis of the cosmic microwave background, Penrose has sought evidence for these cycles, such as the mysterious rings that are claimed to be traces of black holes from previous universes. Yet, this theory is far from definitive. The scientific community is still debating whether these rings are real or merely data artifacts. Nonetheless, one cannot deny the creativity and boldness of the idea. Penrose challenges us to think beyond the standard cosmological model and to consider possibilities that might currently seem unbelievable, such as black holes acting as guardians of past universes, or time being cyclical rather than linear. Ultimately, Penrose's Cyclic Universe theory reflects the dynamic nature of cosmology. The cosmos remains full of unknown secrets, and we are only at the beginning of understanding its wonders. This theory reminds us that science is not just about finding answers, but also about asking grander questions. Perhaps one day we will truly understand what existed before the Big Bang. If Penrose's Cyclic Universe theory is correct, then perhaps we stand at the end of one universe and the beginning of another, without even realizing it. This idea not only changes our understanding of time and space, but also raises profound questions about the destiny of the cosmos. What do you think? Will signs of previous universes be found in the cosmic microwave background?